Greetings and welcome to your geometry week of May 2nd, or we are in week 16. So we are now into May, which is also the month that the last day of school is on. So that's exciting and something to keep in mind that we are getting very close to the end of the school year. So just keep that in mind and also be sure that you are moving in the right direction to ending the class where you want to, with the grade you want to. I do have a warm-up question to get started with, so if you don't have your math notebook out at this time, go ahead and click pause so that you can grab it. And I do want you to try in your math notebook this warm-up question, where I want you to find the distance between point R, which has coordinates -3, 4, and point S, which has coordinates 2, 6. If you need a quick reminder about how to use the distance formula or what the distance formula is, you can do a quick web search. Remember, you guys have tons of information at your fingertips, and if you can't remember a formula, use the internet and do a Google search or any type of search engine that you like to look it up. So go ahead and click pause and find the distance between those 2 points, and then when you're ready to check your work with mine, go ahead and click play. Okay, so we're going to start with reviewing what the distance formula is. So the distance formula lets us know the distance between 2 points when they're plotted on a coordinate plane. And we use this formula that we're going to take the square root, we're going to take the difference between our x coordinates and then square that difference. And then we're going to add to it the square difference between our y coordinates. So we'll subtract the y coordinates and square those. So that's how we find the distance between 2 points. So R, we'll call it our first coordinate. So -3 is our first x coordinate and 4 is our first y coordinate. 2 over here in the second coordinate is our second x coordinate, and 6 is our second y coordinate. So we're just going to plug those into the formula. So the second x coordinate is 2 minus the first one, which is a -3. So we do have a double negative in there because we're subtracting the -3, and then we'll square that, and then we're going to take the second y coordinate, which is 6, subtract from it the first y coordinate, which is 4, and we'll square that. So I'm going to continue up over here. So we've got 2 minus -3, which I know becomes a plus sign. We're going to add those. So 2 plus 3 is 5. 5 squared is 25, and then we're going to add to it 6 minus 4 I know is 2. 2 squared is 4. So I just simplified that up here. Let's go ahead now. 25 plus 4 is 29. And is there a perfect square root of 29? Are there two numbers that when we multiply them together give us 29? There is not. So the most accurate answer would just be to leave our answer as the square root of 29. That's going to be our most accurate answer. If we take the square root of 29, if you plug that into your calculators, you're going to find that the square root of 29 is 5.385164807. So we would have to round. And when we round, we're getting away from having the most exact answer. So just leaving our answer as a square root of 29 is going to be the most exact answer. It's going to be the most accurate rather than rounding out our answer. I'm going to go on to the next slide. So if you need more time, go ahead and click pause. Otherwise, we're going to move on. So this week we're going to continue looking at Unit 8. We're going to do Unit 8, Session 5, 6, and 7. Unit 8, Session 5 is all about angle relationships and not triangles. We're looking at circles in Unit 8. Unit 8, Session 6 is all about segment relationships in circles, and then Unit 8, Session 7, which is also the last session in Unit 8, we're going to look at circles in the coordinate plane. And that's a heads up then that next week the Unit 8 test is coming. Talked a little bit about this already. Yes, we are getting closer to the end of the school year, so just keep that in the back of your mind. So Session 5, let's talk about angle relationships in circles and different angle relationships that we have. We talked a little bit about this last week, but we always had our angle vertex at the center of the circle. And this is not the case in Unit 6, Session 5. So here you can see we've got a tangent line right here, and then we've got a secant. Whoops, sorry, here's our tangent right there. I meant to say, there's our secant. Whenever we have a tangent and a secant, so remember tangent is a line that intersects the circle in one place. So that's why this one is our tangent right here. Here's our tangent line because it intersects the circle in just one place. And then we've got the secant line where we are intersecting the circle in two places. And where those two lines or chords intersect, we've created an angle. So we've got an angle created with a secant and a tangent. So when we've got a tangent and a secant that intersects on the circle, right here, there's our intersection, it's on the circle, then, right, there's our intersection, which is the vertex. It's on the circle. When we have that, the measurement of the angle formed is half of the measure of the intercepted arc. So here is our intercepted arc. Right there. So the measurement of the actual angle is going to be 1/2 of the intercepted arc. So the measurement of the angle is 1/2 the measurement of this arc. And that's a tangent secant angle. So let's use that. Let's use what we just learned to help us find the measurement of angle B. So here's our secant chord and our tangent line right here, and they intersect on the circle, and we want to find the measurement of that angle. And let's look at what we're given. We are given the measurement of the intercepted arc. So we're given the measurement of this arc here, that it's 120. So can we find this angle measurement? Do we have enough information given to us to find that measurement of that angle? Well, remember back here we learned that the measurement of the angle is going to be half of the intercepted arc. So to find the measurement, we do have enough information. So the measurement of angle ABC is going to be equal to 1/2 the measurement of arc AB. And what is that arc measurement? It's 120 degrees. And what's half of 120 degrees? 60 degrees. So the measurement of angle ABC is going to be 60 degrees. All right, I'm going to go on to the next slide, so if you need more time, go ahead and click pause so you can take good notes. All right, so what happens when we have secants or chords that intersect inside a circle? So we just looked at the pattern that we get when they intersect on a circle, but what happens when they intersect inside a circle? Like in this case, we've got two secant lines, or secant chords, or two chords that intersect. We've got two chords. These are two chords because they're not going through. They intersect on the inside of our circle. So here's the pattern. If two secants or chords, in our case these are chords, intersect in the interior of a circle, then the measure of each angle So the measure of each angle formed, these are vertical angles, so they're going to have the same measurement. But each of those angles, and then we've got two other angles that will have the same measurement, this one and this one. The measurement of each angle is half of the sum of the measures of the intercepted arcs. So what we're going to do to find these two angle measurements right here is we are going to, where are we? We're going to add the measurement of this arc plus the measurement of this arc and divide the total by 2. To find the measurement of our other two angles, we would do the same thing with those intercepted arcs. We would add the two arc measurements together and then divide it by 2. So let's see this applied. So here we've got a circle with some chords and we've got some arc measures. And we're going to use the information to first find the angle BXD. So let's find angle BXD, BXD right there. So how do we find that angle measurement? Well, if we look, we see we've got this intercepted arc is given as 70 degrees, and we've got this intercepted arc that's 170. So can you use the information that was just given to you on the previous slide to help us then find the measurement of angle BXD? All right, so to find that angle, we're going to take 1/2 of the total of the intercepted arc measure. So we're going to add 70 plus 170, and then find that total and divide it by 2. So 70 plus 170 is 240. Divide that by 2, and we get 120 degrees. So the measurement of angle BXD is equal to 120 degrees. What about, how do we find the measure of angle BEC? So we just found that this angle right here is 120 degrees. What is the measurement? That's kind of, let me get rid of that. So right here, this one is 120 degrees. Can we figure out now this angle, BEC? We can. So look, we've got a straight line right here. And we know a straight line is the same thing as a straight angle. And we know that in a straight line, there's a total of 180 degrees. We know from here to here is taking up 120 degrees. So to find that missing amount, we can just take 180 and subtract out 120 to get 60 degrees. So BEC, the measurement of angle BEC is going to be equal to 60 degrees. All right, I'm going to go on to the next slide. So if you need more time, go ahead and click pause. So we've learned about two patterns so far. When we've got chords, secants, and tangents that intersect outside of a circle, we've learned patterns when we've got chords or secants that intersect inside a circle. And now we're learning about patterns that occur when we've got tangents, secants intersecting outside of a circle. So here we've got two tangent lines, two tangents, and they intersect outside of a circle. So instead of adding the arc measures together, we are going to subtract the intercepted arc measures. So what we're going to do is we're going to subtract ABC, the bigger of the two, and we're going to subtract from it the remaining arc measure AD, or CDA, ADC, doesn't matter which way you go. And then take that difference and divide it in half. So that's when we have our angle with the vertex outside of a circle. All right, so let's see if we can apply what we just learned. So we're going to look at number 1, where we want to find the measurement of angle x. So we want to find this angle measurement. We're told that AC, so from A to C, is 179.78. And the measurement from C to H is 102. So how can we use that given information to find the measurement of angle x? Well, the measurement of angle x, we take the larger of the two arc measures and subtract from it the smaller of the two. And we get 178 minus 102, and I get 76. So the measurement of angle x is 76 degrees. All right, and looking at number 2, I want you to now see if you can solve number 2 on your own. So I would like for you to click pause and try this in your math notebook. Remember, you get a lot more out of this doing it on your own first and then checking your work with mine. So go ahead and click pause and see if you can find the measurement of arc CH. So now I'm asking you to find the measurement of an arc. All right, so we know that the measurement of angle x has to be equal to 1/2, I'm just going to set up the equation, the measurement of arc AC minus the measurement of arc CH. And then we're going to plug in the given information. So we know that the measurement of angle x is 68 degrees, that was given. And then, do we know the measurement of arc AC? We do. It's 158. Do we know the measurement of arc CH? We do not. There's the question mark because that's what we're trying to find. Alrighty, so the first thing we want to do is get rid of this 1/2 on the right side of our equation. So the easiest way to do that is just to multiply each side of our equation by 2. And that cancels out that 1/2 on the right side of our equation. Then we're going to take 68 and multiply it by 2. And the 68 times 2 is 136. And then we've got 158 minus the measurement of arc CH. So we're trying to solve for the measurement of arc CH. So I need to get rid of this 158. So to get that to go away, we're going to subtract it from both sides. 136 minus 158, and I get negative 22 equals negative measurement of arc CH. If you want to, you can get rid of that measurement of arc CH and replace it just with a variable, if that's easier for you. We don't want a negative, so we're just going to divide each side by -1 to get rid of the negatives there. And our final answer then is that the measurement of arc CH is equal to positive 22 degrees. So I'm going to go on to the next slide. If you need more time, go ahead and click pause. All right, you're going to go on then to learn about the chord product theorem, where that means you've got two chords that intersect in the center of a circle. So if you take one chord, A, the segment of the chord AE, and multiply it by the other segment of that same chord, EB, it's going to be equal to CE times ED. I'm not going to go in depth about that because I do want to wrap this up. And just kind of see, you're going to learn about all different kinds of other segments that occur when you've got segments and angles inside a circle and outside a circle. I do want to quickly go over the equations of circles in a coordinate plane. So I did not go over everything. Obviously, I can't go over everything for the week in a 20-minute recording, but I do want to go over the equation of circles in a coordinate plane, just to introduce that to you. So we can draw a circle on a coordinate plane, and we actually have an equation for a circle on a coordinate plane. Just like for a line, it's y equals mx plus b. We also have an equation to help us draw circles on a coordinate plane. And here is that equation right here. So the equation that helps us draw a circle on a coordinate plane is x minus h squared plus y minus k squared equals r squared. And I want you to write this down in your math notebook right now. So in order to help us draw the circle, we need some key characteristics or key points here. One of the key points is our center. So where is the center of our circle? Well, the center is given to us by the numbers that are going to be substituted in for the h and the k in this equation. So remember, just like we have y equals mx plus b, and we substitute in numbers for the m and the b, you know how we substitute numbers in for the m and the b, we're going to substitute numbers in for the h and the k. And those numbers are going to represent the center of our circle. So the center of our circle is represented by those numbers that are substituted in for h and k. Now keep in mind that the general form of the equation is x minus h, y minus k. So if we have an equation like x minus 1 squared plus y minus 6 squared, then our center would occur at 1, 6. Those negatives aren't part of the h and the k. The negatives are part of the general equation. So that would be where our center is. It would be at, the coordinates would be 1, 6. All right, so the r represents the radius. The r represents the radius. So once we can plot the center, the radius tells us how far to go out from the center. That's what the radius is. So we're going to always take the radius and square it in our equation. And we're also going to replace the r with a number. So the only thing that stays as letters is going to be the x and the y. So now it says, what is the equation of a circle has a center with the coordinates 4, 6, and a radius 4? Well, we always start by saying x minus, well, there's my h and there's my k, because that's what the center is represented by, hk. So x minus 4 squared plus y minus k, which k is 6, squared equals our radius. My radius is equal to 4, but if we look back, the radius is going to be squared. So 4 squared is 16. Ta-da! That's the equation of the circle with center 4, 6, and it has a radius of 4. All right, and then the next one, let's do one more of these. It says, what is the equation of a circle with the center? Remember, that's represented by hk of 2, negative 3, and a radius of 2. So our general equation is x minus, well, h is 2. Plug that in, square that. Then we've got y minus, my k is negative 3, square that. So now there's a double negative, so I can make that a positive. Set that equal to the radius is 2. We need to square the radius. 2 squared is 4. So that's the equation. I'm going to go on to the next slide, so go ahead and click pause if you need to. There's lots of information on here, so clicking pause and taking good notes will really help you this week. All right, so now I want you to work backwards, and I've already written down the equations of some circles, and I want you to tell me just in number 1 what the center is and the radius is of that circle from equation 1. So go ahead and click pause and see if you can do this on your own, and then check your work with mine. So remember, the general equation is x minus h. That negative or that minus is part of the general equation. The h and the k are what tell us the center. So there's my h, it's 5, and there's my k. I've got the minus in there, but that's part of the general equation. The h and the k are actually positive. So there's my center. What about the radius? Well, remember, it's r squared, so to find the radius, we need to take the square root of 36. The square root of 36 is 6, so 6 equals the radius. If I square 6, I get 30. And one more, let's do one more here, this last one. So I want you to find the center and the radius. So click pause, try it on your own, and when you're ready to check your work with mine, go ahead and click play. All right, so we've got x plus 2. Remember, x plus 2 we can rewrite with a double negative, and that will help us see better what the coordinates of the center need to be. So here, my center is going to be -2, because we've got x minus 2, and then the k value is going to be 7. So the center would be at -2, 7. And my radius, we take the square root of 49, which is 7. So just an example of where you can have a negative coordinate as your center and what it looks like when we have it written in the equation in standard forms for the circle. So again, write this down in your math notebook, the equation in standard form for a circle. And the HK represents the center, and the R squared is our radius. And remember, it's squared in our equation. So to find the radius, we have to take the square root. I'm going to go on to the next slide. So go ahead and click pause if you need to take down more notes. We're going to go ahead and finish up this recording and do the key phrase assignment. So let me write that down. So I've got an equation written in standard format of a circle. I've got x minus 4 squared plus y minus 6 squared equals 81. All I want you to do from that equation is tell me what is the center of that circle. What is the center of that circle? And that's it. So that's a wrap. Let me know if you have any questions or you need any help as you're working through this week's assignments. Have a great rest of your week.